Hey everyone, and welcome back. Today, we're going to dig into a really fascinating search technology called ColBERT. It's an approach that's all about finding exactly what you're looking for by, well, not losing the details along the way. So let's jump right in. So let's start with a big question. Think about this. When we use AI to search through huge amounts of text, are we kind of losing the plot? Are we accidentally throwing away the very details that actually matter the most? This is the exact problem that ColBERT was designed to fix. And the whole issue really starts with what you could call the single vector problem, right? Imagine trying to summarize a whole book with all its characters and plot twists into a single sentence. You're gonna lose a lot of the good stuff. Okay, so this is really the fundamental difference in thinking. On the one hand, you have your standard models. They take an entire document and basically squish all of its meaning down into one single vector. It's a summary. But ColBERT, it does the exact opposite. It says, let's keep the full text, and instead, let's create a separate vector for every single word, every single token. It's a way more detailed, granular way of looking at things. And this quote from one of the source papers it hits the nail on the head. The feeling is that it's overly restrictive to expect one little summary to capture everything. And that specific frustration, that limitation, is what really sparked the search for a better way to do this. So what is that better way? What's the alternative? Well, instead of comparing these big, blurry summaries, what if we could compare documents on a word-by-word basis? Or, to be more accurate, a token-by-token basis. This is the really powerful and honestly intuitive idea at the heart of ColBERT. And the name itself, ColBERT, actually gives you a huge clue about how it works. It stands for Contextualized Late Interaction. Contextualized means every token, every word, knows what it means in that specific sentence, and the late interaction part, well, that's the secret sauce. It means the real heavy lifting, the actual comparison, happens much, much later in the process, at that super detailed token level. Okay, so we keep saying late interaction. What does that actually look like in practice? How does a ColBERT search really happen? Let's walk through the nuts and bolts, step by step. It really boils down to this pretty simple three-step process. First up, tokenize. Everything, your question, your documents, gets chopped up into individual tokens, and each one gets its own vector. Step 2 is match. Now, for every single token in your question, the system scours the document to find its one single best partner. And finally, score. You just add up all of those best match scores, and that's your final result. Simple as that. All right, let's try to visualize this. Imagine we take just the very first token from our question. It has its own unique meaning, its own little vector representing what it is in that context. Now that one little token goes on a mission. It gets compared to every single token in the document that we're searching, and it's looking for just one thing: the token with the highest similarity score, its perfect match. Once it finds it, boom, we lock in that score. And here's the key: we don't just do that once. We run that entire process again for the second token in our question, and the third, and so on, finding the best match for each one. The final relevance score for the whole document is just the sum of all those individual best match scores. It's a really elegant system, because it's not averaging things out and losing the signal. It's rewarding the absolute strongest points of connection between your query and the text. Okay, this all sounds pretty amazing, right? But as you know, in technology, there's rarely a free lunch. So we've got to talk about the practical side of things, the trade-offs. We need to look at performance versus speed. So the huge upside, the big win for ColBERT, is that it has what's described as very strong performance. Because it's doing this incredibly detailed token-level analysis, it gets really, really good at finding highly relevant, super nuanced results. And at the end of the day, that's what we want from a search engine, right? But there's always a but. All of that detailed work, all that computation, well, it takes time. Comparing every query token to potentially thousands of document tokens is a lot of work, and that can lead to higher latency. Or, in plain English, it can just be a bit slower. So let's just lay it all out on the table. On the one hand, you get these incredible benefits: higher accuracy, really nuanced matching, and it's especially great for longer, more complex documents. But on the other side of the coin, you have to consider the higher latency and the extra computational cost. It basically means you have to do a production readiness check and ask yourself, is this trade-off worth it for my specific application? Now here's the really fun part. This isn't just some abstract concept locked away in a research paper. You can actually get your hands dirty and experiment with ColBERT right now. Let's take a look at how.
Getting started is actually way easier than you might think. There's this fantastic library called Ragatouille, that's Ragatouill, that just wraps everything up for you. You can pull down pre-trained models, you can index your own documents in just a couple lines of code, and it even plugs directly into popular frameworks like LangChain. It just works.
And check this out. This is what it actually looks like to run a search. It's clean, it's simple, it's just so accessible. That's the real magic here, I think. This incredibly powerful, nuanced technology isn't some complex beast you have to wrestle with. You can just call it with one line of code and see the results for yourself. So this all leaves us with one final, pretty big question to think about. With its incredible ability to capture all of these fine-grained details that other models might miss, could this token-by-token approach be the actual future of semantic search? It's a really powerful idea to consider. Thanks for digging into this with me today.